Okay, we're going to do the buffer problem on quiz 3, number 1. So the first question, is this just an acid-base problem or is it a buffer problem? It's definitely a buffer problem because I already told you that it's a buffer problem, and it says buffer, and it has a concentration of a weak acid and a concentration of its conjugate base, and that's the definition of a buffer. So buffer, 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 this is going to be governed by the Henderson-Hasselbalch equation, which I better write down. Okay, now when we look at the composition of the buffer and what the question's asking us, you should just read it through and get it straight in your head. So I've got a liter of this phosphate buffer. It's made of the acid at that concentration, and here's its conjugate base right here at that concentration. Those are equal concentrations, so this is an equal buffer. That's interesting. Maybe I'll write down, the equation that governs this buffer. Here's my acid, and it's going to dissociate to form my conjugate base. Here's my HA. Here's my A minus. It's good to know. It tells me what the pKa is. It doesn't tell me what the pH is, but it wants to know what the final pH would be after I insult it with some strong base. Okay, so let's first define this buffer. I need to know a little bit about it. Maybe I don't, but I'd probably first solve for the pH of this. pH equals pKa, tells me what that is, plus the log of base, tells me that, 2.10 millimolar, and the acid has the same concentration. And so, since this is an equal buffer, the pH of that buffer is equal to the pKa. Log of 1 is 0, so the pH equals 2.12. Well, I don't really need to know that, to be honest, to do this question, but a lot of times it is nice to know what the pH of your original buffer is. Now, if I focus on the question, it's saying what would be the final pH of this buffer after I add 1 milliliter of a 1 moles per liter solution of sodium hydroxide. Now, the unknown in this case is the new pH. The pKa is going to remain the same. It's a constant that defines the equilibrium over here. And the concentrations of my acid and base are going to change because I'm adding this strong base. Now in class, if you remember, I said it's kind of nice conceptually to change the concentrations of the base and the acid into moles. And so I have a 10 millimoles per liter solution. Let's just keep that at 10 millimoles, right? I'll just say I have a liter, and that's fine. I also have 10 millimoles of my acid. Now, for every mole of sodium hydroxide that I add, it's going to react with a mole of my conjugate acid and convert it to a mole of the conjugate base. That's what buffers do. And so, since I'm adding strong base, I'm going to be removing acid and adding to base. That's the first thing you got to get straight. Then you have to figure out, well, how many moles or molecules of base are being added. Well, I'm not told directly, but I'm told that I'm adding 1 milliliter of a 1 mole per liter solution. So if I have 1.00 times 10 to the negative third liters of a 1.00 moles per liter, I end up with 0.001 moles of hydroxide or sodium hydroxide added. And again, for every mole of strong base, I'm going to lose a mole of acid, and it will be converted to a mole of base. Okay, now here I'm sort of mixing up my units a little bit. I've got millimoles here and I've got moles there. If I change 10 millimoles to moles, it would look like this. Same up here. And so my Henderson-Hasselbalch would be converted to this. pH equals 2.12 plus log of 0.01 moles plus 0.001 moles. So I'd have 0.011 moles. I'd have a little more base than I had to start with, my conjugate base. And then I'd have a little less acid because 1 millimole has reacted with the base. So let's just do the math here. My new pH equals 2.12 plus log of 0.011 divided by 0.009 equals log of 1.222222. Where's my log? Boing. So if pH equals 2.12 plus 0.0872, I'll just wait till the end here to do sig figs. So pH equals 2.21 is my final pH. Now usually I'll ask if this makes sense. Well, my original pH was 2.12. That was my original buffer, and then I insulted it by adding a little bit of strong base. So I would expect my pH to go up a little bit, and it did. Okay, so that's good. If I had a pH lower than 2.12, I would have suspected that I had gotten my pluses and minuses backwards or something like that.